All right, let's see this time if the data given to you is having frequency as well. Okay, so now you're having table below here. They show you the time spent in minutes, okay, eating lunch of high school students. This is 35 minutes. 3 students took 35 minutes. 36 minutes, 17 students, right? 37 minutes, 29 students. 38 minutes, 34 students. So as you can see here, yeah, all the data are given to you. Now the question say calculate the standard deviation. Okay, so what do? I'm going to use the same formula again here for variance. So this time it will change a little bit. So if you remember the old time, the formula for variance was sum of x squared, right, over n minus the mean being squared. So this time all I need is just change this. Okay, let me rewrite this. Minus sum of x over n, the whole thing being squared. Yeah, so you can compare here. What I'm doing is I'm changing this guy by multiplying it with frequency. See, so this is being multiplied with frequency, and then n, total number of data, is just changed to sum of frequency. Okay, how about this guy? This guy, I'm just multiplying it again with the frequency, right, over the sum of f, the whole thing being squared. See, all I did was just put the f on top, okay, and simplify it. Now this is the variance. If you want SD, what you will do is you will take the square root of what you have here, right? So that's what I did here. Okay, let's see. Now I'm going to make this table. So see, you're given this table. I want you to extend this table and write fx square. Okay, here. So fx, take this times that, write it here. Fx square. See, take this guy, multiply with this guy being squared, and write it here. Okay, same thing. So this is 17 times 36. This is 17 times 36 square. Okay, so you fill all this whole table and then you add them, write the answer on the bottom. Okay, all right, let's see, what do I get? Now I had simplified it for you here, you can see. So add all this up, you will get the sum of fx. Okay, and add all this up, you will get the sum of fx square. Okay, and n is total frequency added up. This is n, or sum of f. Okay, now all I need is just plug everything in place. Okay, so if I'm asking you how do you find the mean is easy. Just go with this, sum of fx over sum of f. In this case, it's 4096 over 109. Okay, then let's see, 4096 over 109. This is 37.5. I'll go with 0.6, yeah, round it up. See, this is the mean. I can say this is same as this guy. Yeah, so you can replace it. Now let's see, what do I get? Sum, the variance, this is SD, yeah, is equals to sum of f, which is given to me as this, divided by 109 minus the mean square. Okay, so you punch all this in, you will get SD, standard deviation, which is equals to 1.09. Okay, which means the data given to you, or your data given, is not that much spread out. Okay, so the data are actually concentrated. It will be something like this. If you plot the graph out, your graph will be somewhat like this. Okay, so the data are clustered together. Okay, so clustering together means that the data is not that far from each other. So what if my SD is this 10.9? Okay, let's see. If it is 10.9, your data are quite different in the height. Okay, so maybe something like this. See, so this is the difference between the two. Okay, all right, now moving on. So you can have a question like this. All right, let's see another example here. So this is a table given to you. It is showing you the time spent talking on the phone of EIS student each day in school, right? So the length of time that they talk on the phone, this is 0 to 5 minutes, you have 4 students, right? This is the frequency. 5 to 10 minutes, you have 15 students. 10 to 15 minutes, you have 5 students. 15 to 20 minutes, you have 2 students. And then 20 to 60 minutes, 0 student. And this is 60 to 70 minutes, you have 1 student. So the question is saying that calculate the standard deviation of the data sets. Okay, so how do we do if the data are given in class? This is in class, yeah. So what I'm going to do is I will start by looking at this data and find the midpoint here. Okay, let's see here. So I'm going to construct a table here. This was given, right? These two were given here and here. So I will make this up. First table, midpoint, I called it X. Then second table, frequency times X. Then third table is frequency times X squared. Okay, so you can see here the midpoint from 0 to 5 is 2.5. Okay, let's fill all the midpoints first. The midpoint here, again, 7.5. The midpoint here, 12.5. The midpoint here, 17.5. Then midpoint here, 40, right? And then midpoint here, 65. Okay, I got all the midpoint out. Now you write fx. This is f, this is x. Multiply them. 1 times 7.5. 5 times 12.5, and then just keep on writing it. All right, this is 0. 1 times 65. Okay, then here, don't forget you have to square the x. So here, this guy, this is 4 times 2.5 square. Okay, 1 times 7.5 square. 5 times 12.5 square. 2 times 17.5 square. 0 times 40 square, 1 times 65 square. So what I'm going to do next is I will not punch in one by one. I will punch the whole thing out and write the answer here. Okay, and here the sum of the students, add them all, write it down here. So this is 5, 10, 12, 13. So I have 13 students. And this you do punch in the calculator. Same here. Punch the entire thing in the calculator. So this is the sum of f. This is the sum of x, fx. This is the sum of fx squared. So again, I only needed these 3 values from here. Okay, for me to find SD. Now let's say I did all and I got all the 3 values that I'm looking for. Okay, what do I do next? Here, taking all the 3 values, I will punch them in the equation I have. So this is the equation that I'm going to use to find SD. Okay, first value here, put this in here. Sum of f, 27, you put 27. Okay, sum of f times x divided by sum of f. Okay, so this is 285 over 27 and square it. Okay, so simplify this whole thing out, you will get equals to 11.35.